Welcome back to our Scala to Spark class, and again we just saw a basic introduction to our machine learning, and we saw the R formula used in our code, and we got to also, after the transforming our data, we also split the data into training and test set. But let's go talk about a little bit about this R formula, at least give you an idea, so it doesn't look like complete black magic, right? So again, in my opinion, it's one of the strongest features. It's one of the neatest features in Spark. Again, even though I'm not an R programmer, but I do use from time to time. But this ability to use this syntax is quite powerful, right? Because it saves you a lot of time of doing some transformations column at a time. It gets you the features and labels immediately, basically. So let's explore this in a moment. So let me create a new Scala class object day 32 R formula, right? Add extends app, right? Print line. I think it's chapter 25. R formula for transformations. Again, it is something I think it should be used more often. And let me show you the documentation for it. Right. So it's under here in Spark. So there are only a few things you have to know from this. Basically, it's a way of transforming our columns into using a few operators into the needed other columns needed for machine learning tasks and other things. So this is for separating target and terms. So target means it's a label basically, and terms is of course the actual features basically, right? So plus we basically concatenate the terms, right? So remove terms if you want an interaction we saw in our example, maybe slightly more complex. Also very common is dot operator, which means you want to have all columns except the label, right? So let's take a look at an example, right? So we'll have some data set, right? I'll of course we'll need this our data set, right? We're not going to use Spark at all. I mean, we'll use Spark features. So if I do this, right, this won't work, right? There's a Spark data frame, and this is actually need, of course, Spark, right? So this is one way of doing it. So I'll do val spark get sparky, of course, right? And then this works. Now I don't need an implicit, so of course clicked, and I can show, of course, data set, right? Show, right? So let's see that. So we have three rows, right, and 4 columns, right? ID, country, hour, clicked. Right? Very simple data frame, hand-picked, basically, right, to show you what's happening underneath. Again, I'll try not to say, yeah. So it works. Okay, 7 ID. Okay, great. So now let's see this formula. We'll use the R formula. Basically, we can also figure out the name and label. All right, and this will actually be our transformation. So you don't really need the full. These are actually default values, by the way, right? My features, my label, right? So we'll see what happens if I do. Usually you want to keep, these are not required actually. So we'll see how it works. So notice how it works. We have a formula fit, we have our data frame, and we do a transformation on it, right? Immediately here. Notice how in our previous example, in our code, right? And of course I need to import it, right? Here, right? Okay, so I'll just do basically, I'll show everything, right? I'll show everything. We don't need all, right? So you'll see that, right? Output, you'll see everything. So let's see what's happening. So basically, this is only tricky part here, right? So we are saying we want the label be from clicked column, right? On country and our columns to be used for features, right? Again, right? So again, so let's see, and of course these are default. I believe it is actually just default. I think it's the we'll test it afterwards. We'll see if this actually works. I'll say maybe, my features and my label, right? My label, right? Let's see that. And default, I think, is features. Default is features, which is fine. And of course, this is also default is label, which is usually fine. Okay, let's run it and see if this little code performs as expected. Yes, it works. See, my features, my label. So only thing what might be kind of a little bit confusing maybe is how does this work? What's happening underneath here, right? So 0, 0, 1, and 1, right? So turns out, if you read about this documentation, how does it work in? So how does it work with string values? Well, it's kind of interesting. So it casts using string indexer, right? Meaning, of course, gets a numeric value, right? But then it does one-hot encoding, which also, remember our one-hot encoding, and if you talk one-hot encoding is basically saying something like this. It's very, very, very common. One-hot, right? Something like this, right? You have multiple values, right? You say here, let's say apple, chicken, broccoli, right? And you basically generate one-hot encoding. Say, okay, this is apple column, this is chicken column, this is broccoli column. Okay, and so it's one of these is hot. However, this is not all that's done here, right? I don't know if it's mentions, right? It's right. I don't know. It is so it's mentioned here. It drops last category. So why would it drop one category? So why? Well, it turns out it's for saving. You can save a column. How? If it's all zeros, right? If none of the values are zeros, that means it is actually, the first category, whichever by some ordering. So let's say US, it's probably US here. So this represents US, this represents California, Canada and New Zealand, right? Okay, let's see, let's add one more country, right? I'll add one more country, I'll add Latvia, right? LV, right? LV. And I'll do, I don't know, 212, right? And the answer, again, this is just a label, right? Let's leave it there. I'll look, I don't know, 10, whatever, right? It doesn't really matter. Okay, let's run it again. So if my explanation is correct, there should be a double once. No, should be a new hot column for LV. Okay, if it's one hot encoding. Let's take a look at this. If this really is the case, so there should be one new column. Let's see, that's a country, 215. Indeed. So notice something interesting here, right? So here this is, so US is excluded. So basically US has first 3 zeros. There is why is California and the New Zealand and Latvia? What's the story here? Basically, there's, I think it's why is it one here? There is a way of specifying which how to encode it, the order here, right? There's a way to have a string order type. Again, it's usually we don't really care about this. I mean, it matters what do you drop. So it's a slight tiny optimization. Basically, we dropped one column in this one hot encoding because, well, if none of these are set, if none of these flags are raised, then that means that this is a current. This is encoded this one. So I hope you see the problem is one hot encoding. Well, it is not. It generates 0 or 1 values, numerical values, which is good for machine learning algorithms, right? But the problem is, of course, it will tend to generate very, very sparse data sets. Okay, let me add Lithuania, right? Right, Lithuania. That's again, the numbers are completely arbitrary. These are just the ID values. We're not using them, right? So I don't know, whatever. Right? These have no values. 1, right? Which is fine. I can do also 55, right? Okay, label, right, is double again. So that's fine, right? But it will generate one more flag, right? This will be 5, and it will be another flag here somewhere, right? It needs to store all these different values, right? So let's run it. Question, of course, is the algorithm, how it picks the first most frequent one. But let's take a look at this. So we expect to see 5, right? And of course the last column will be always filled, right? So why is last column always filled? Is because our formula says country now. So this country is starting to eat up extra columns because it's a string column, right? So we'll see Lithuania. Yep, like I predicted, 5, right? So 5 columns now because 4 of those are taken by these one-hot encodings. Of course, all of these rows have features have 4, 4, 4, 4, right? Because that's the last value here. Okay, so and of course click label. Of course, it's easy. There is nothing to do here. That is easy. You could of course even skip this, right? Because this is already a double, right? You didn't even have to. You created because you didn't have to use this because you already had it already already it was already ready to go. You could just rename the column to label if you want, or just duplicate column. But again, this shows you again. So this first entry before the tilde symbol is the answer column, so to say, the label column, and the rest are basically the columns you want to use as features. Again, you have to squeeze them into one vector. Basically, this is a sparse vector here, right? And you'll have the answers. Okay, so before we go to the stop recording, yeah, we want to do an exercise, right? So what I want from you to do, so your exercise is to do load or what you call it, or from by day, retail data by day, load into data frame from December 1st, from retail data by day December 1st, right, and which you already know how to do very well, right? We've been doing this all the time. And then extract, create RFormula to use country as label, and only unit price and quantity as features, right? So that's again, you can leave names, column names as default, right? At default. Okay, and then of course create transform, create a new output data frame with the fit on transform columns, basically, right? With the formula performing fit on transform, right? Just like an example, right? So for those who adventures, bonus, try creating features from all columns in the December 1st CSV, except of course country, right? So see how that using dot syntax, right? This will be right. This should generate a very sparse the column, right, of features. Okay, so to do bonus, that's your exercise, right? So again, so that's a bonus if you want to do everything except country, right? Of course, that will be kind of silly, but you'll see that might be worth trying again. So, right, see how that works. All right. So again, so this is the label, and these are the column names you want to use, basically, right? So, but again, so this is right. So quantity as features, right? Hopefully they are, but of course to do make sure they are numeric columns, right. We don't want here, we don't want, right, so this is this because of one hot encoding. Yeah, we do not want one hot encoding here, right. All right, so all right, and that's it for today, and we'll meet at 9.